Alright, let's check out 4.6, segments related to a circle. So with question 1, you'll notice that we have a secant segment as well as a tangent segment. So we're going to use the tangent-secant power theorem. And what that states is that the tangent segment squared is equal to the external part, so 18, times the entire secant segment. So if you look at that entire secant segment, it's not just x or 18, it's x plus 18. So x plus 18. And I'll do this in green so you can tell. X plus 18. So that's what that theorem states. Now all we have to do is evaluate. 30 squared should be 900. And then we distribute 18x plus 18 times 18. What is that? 324. 324. Subtract 324 from both sides. We get 576. Okay, so 576 is equal to 18x. We divide that by 18, so we divide both sides by 18. We get that x equals 32. You'll notice on this second problem, we have a secant segment and a secant segment. So for the secant-secant power theorem, we know that it is the external part of one secant segment times the entire secant segment is equal to, you'll take the external part of the other secant segment, so 9, and you multiply by the entire secant segment. So that's 21 plus 9, right? That entire segment is 21 plus 9. We'll just simplify this here and say 30. So we get 10x plus 100 is equal to 270. Subtract 100 from both sides, we get 10x equals 170. Therefore, x equals 17. Okay, it looks like the next two questions are chord-chord. And for chord-chord, you have to first look at one chord. So let's take a look at this chord, where we have x minus 6 as one part and 9 as the other part. Basically two segments of the chord you multiply together. So we get 9 times x minus 6, and that should be equal to the two segments of the other chord multiplied together. So we get is equal to 6 times x minus 4. Distribute. Let's start by subtracting 6x from both sides. We end up with 3x is equal to, and then let's add 54 to both sides. Kind of doing two steps in one right here. So 6x minus 6x, 0, negative 24 plus 54, that should be 30, right? So we know x equals 10. Oh. That's the key. Alright, another chord there. Maybe we'll go with this chord real quick, because there's more x values, and I'm sure we'll end up with a quadratic. So once again, you take two segments of one chord, see there's two segments here, and you multiply them together. X plus 1 times 4x minus 2. And that is equal to, and you must look at the other chord. It's two segments here. So we have is equal to 2x minus 1 times 3x minus 1. You distribute. You guys very much need to know how to do this. FOIL. First times first. That's 4x squared. Outer times outer. That's negative 2x. And then we do, let's choose some more colors so you guys can see this process. Plus 4x. And then finally, last times last, which is negative 2. And this is all equal to first times first. Actually do that in red. First times first. So that's 6x squared. And then we do outside times outside. So that's negative 2x. And then we do, in gold, inside times inside. So that's minus 3x. And then finally, we do last term times the last term. So that should be plus 1. So I'm going to simplify this. We'll combine like terms here. That's 2x, 4x squared, plus 2x, minus 2 is equal to 6x squared. Combine these like terms. That's negative 5x plus 1. Alright, so perhaps we should start by subtracting out 4x squared from both sides. See what that gives us. We get 2x minus 2 is equal to 2x squared minus 5x plus 1. It looks like it's going to be a quadratic. That x squared doesn't cancel, and neither do the x's. So we're going to want to get everything to one side and have it all equal to 0. That's our quadratic equation. So we'll add 2 to both sides and subtract 2x from both sides. So this is 0. And then this here is 2x squared minus 7x plus 3. So our product, you should know this, is the leading coefficient times the constant. So our product is 6, and then our sum is negative 7. So what two numbers multiply together to get positive 6, yet when you add them together you get negative 7? Negative 1 times negative 6 equals positive 6. And negative 6 plus negative 1 equals negative 7. So that's the values we use. Those are the values we use. So let's do this. We're splitting that middle term. That's the whole point of this process. 2x squared minus 6x minus 1x plus 3. This allows us to use the box. 2x squared, negative 6x, negative x, positive 3. Greatest common factor here is 2x. Greatest common factor in this first column is x. X times negative 1 equals negative x. This is where I'm looking. Since I know this belongs here, and the product ends up being negative x, we know that this must be negative 1. So that our product between x and negative 1 is negative x. And then, negative 1 times what equals positive 3. So we should say it is negative 3. Double check that where items cross around. So 2x times negative 3 equals negative 6x. Okay, that works. So x minus 3, and then 2x minus 1 equals 0. This is our factored form of this equation here. Factored form is important because it allows us to find the solutions for x. So x minus 3 equals 0 will give us one solution, and then 2x minus 1 equals 0 will give us the other solution. In the first case, we have x equals 3 if we add 3 to both sides. And then in this one, we can add 1 to both sides, and we end up with 2x equals positive 1, and then divide by 2 on both sides. Therefore, we have x equals 1/2. So here are two solutions for number 8.